So distance is the extent of space between two objects or places, and people tend to use distance and length kind of interchangeably. One thing that we'll want to remember is distance is never negative. And if you think about that, if you walk a mile forwards, like straight forwards, or you walk a mile backwards, like you're walking backwards, you still walked a mile. There's no, I walked a negative, I didn't negative walk a mile. So distance is always going to be positive. That's just for when you're solving things later and you're solving for distance. If you get a negative number, you kind of should trigger you that this can't be right. Congruent is to have an identical shape and size. So if the area of a square and the rectangle are the same, they're still not congruent. They might be the same size, but they're not the same shape. So you have to be the same shape and the same size to be congruent. And you never have to write this word out. You can always just use this symbol right here. And what you have is this is the symbol for similar, which is the same shape. And then this is the symbol for equal, which is the same size. So congruent is both similar and equal. So you get those two symbols together. Okay, bisect. The prefix bi means two. So to bisect something is to cut it into two equal halves. So having it. A segment bisector can be a point, it can be a line, it can be a line segment, it can be a plane, it can be a ray. Anything that cuts a segment into equal halves. So if you bisect something, each half will be the same size or same length. A coordinate we're talking about in a three-dimensional space. We have our x and y axis. That's our y axis. This is our x axis. We have some point up here, x, y. That's our coordinate. And if you're using letters other than x, y, you can use any letters to name a coordinate. They're always alphabetical. So you know if you're using P and Q, P comes before Q, or if you're using D and Z, it'd be DZ. So it's always alphabetical in the parentheses. Represents the orders of numbers. Measuring is not just length, but it's also volume, it's dimensions, it's quantity. Midpoint, though, this one you really want to know. This is the important one here. Midpoint is the point at the middle or the center from the ends. So if I have a line segment here and here, and this is my midpoint, right there, this length, so we'll just say it's 10, will be exactly the same as this length. So midpoints bisect. So midpoint is a bisector. Remember, postulates are things we accept as true without proof. This is one of the first kind of postulates that Euclid came up with. That the points on a line can be paired one-to-one with real number coordinates. And that the distance between any 2 points equals the absolute value. Remember, absolute value is always positive. So absolute value is just positive of the difference of their coordinates. Okay. Then we have the segment addition postulate, which tells me if B is between A and C, then I can take AB's length and I can take BC's length and add them together and equals AC. So a picture of that. Here's A, here's C, here's B. This length plus that length will equal this whole length. And again, it's a postulate because it's one of those things where if you look at it, well, you go, well, of course, if I take this piece and this piece, it equals the whole thing. Right? It makes sense. We have the midpoint postulate, which tells you that a segment has exactly one midpoint. And if you think about that, that's another thing that kind of makes sense. The midpoint is the halfway point. So there's only going to be one point that's exactly halfway. On a segment, yeah. No, can't have it on line, can't have it on array. Because they're forever, yeah. So here's my midpoint. And so again, this length here will be the same as this length here. And there's nowhere else I could put that point where this would be true. Because even if you moved it over like a micro fraction of an inch, it's no longer equally in the middle. Oops. Okay, so ruler postulate tells us that the distance between any 2 points is the difference, the absolute value of the difference. Basically, is if I tell you to find the distance between any two numbers, so to find the distance, do the greatest minus the less, or least. Okay, so 7 is bigger than -3. So instead of doing -3 minus 7, if you do 7 minus -3, you don't ever have to worry about absolute value part of it. It's just always going to be positive that way. To remember that two negatives make a positive, I draw that and see how it looks like a little happy person. And happy people are positive. So minus a negative is the same thing as a plus. Other people do that. Make it a big giant plus. And then I have seen this as well. But I don't really like this one that much because people tend to confuse it and change negatives they're not supposed to. So I don't really recommend this one. If you want to make it a big plus, if you want to make a smiley face, or if you just want to remember double negative is a positive, either way, the distance is 10. I need to put that somewhere else. We can use a number line to show this if you want. You can go, okay, I want to know the distance between -3 and 7, and I count 10 spaces. Okay, so if you want to use a number line, you can. Same thing. Any questions on that? Okay, now if you did do this and you said -3 minus 7, you'd get -10. Just remember that distance can't be negative. And so that means you need to take the absolute value of it, which makes it a positive 10. Okay? So it's not wrong. It's just you can't be negative, so you have to make it absolute value. Okay, we can use the segment addition postulate to add distances. So I got this figure here, and I want to say AC. AC is AB and BC. So I add them together. And so AC is equal to AB plus BC, 6 plus 2, 8. And if I wanted to find AD, I would have 6 plus 2 plus 7. Or BD would be 2 plus 7. So you just look between the numbers, or between the letters, and add up all those numbers. Not too bad? That would just be 7. So if I asked you CD, you'd just say 7. BD goes from B2D, so you'd have 2 plus 7, so it would be 9. Not too bad? So AD is going to be 15, and BD would be 9. Okay. Okay. We can use this with midpoint and some algebra. So let's say I want to find this length, PR. And I don't know these individual lengths, but I have algebra. And Q is a midpoint. And that tells me that these two things are equal, because a midpoint cuts things into equal halves. So to solve this, I'm going to set those equal to each other. I'm going to subtract x from both sides. So that gives me x minus 5 is equal to 3. Add 5 to both sides. And x is equal to 8. Now a lot of people stop here. And this gets you half credit. We did find x, and that's correct. But we're supposed to be finding the length of PR. So we're not finished. So what I can do is I can plug in x to either side. I'm just going to plug it in right here. 8 plus 3 is 11. Well, if this length is 11, then this length is also 11, because they're equal. And that makes the whole thing 22. So let's look some others. Why don't you guys do RT and RU real quick, A and B? Oh, yeah. This, with that over that, that means the line segment RT. Okay. Without the line, this means the length of RT. So when there's no line, we're talking about the length of the segment. When there's a line, we're talking about the actual segment. So like the physical, it'd be like I'm talking about the pen, this actual pen versus the length of the pen. That helps. Okay. Thank you for, that's a good question. Okay, for C and D, we have the words between and we have midpoint. So these are going to be set up differently. Or the math part will be set up differently, but the picture will be the same. And my recommendation is, at least until you get more comfortable with this kind of problem, you draw the picture. So I have M is between L and N. So I'm going to just draw a line segment with an L and an N, and I'm going to put M between it. Okay, that was the first sentence. LM, that's this little piece right here, is 2x plus 1. So I'm going to label that. MN is 3x minus 2. So I'm going to label that. LN, that's this entire length here, is 24. And we want to find x. Now, because we're given the whole length and we're told that this is between, the word between just means anywhere in between. So there's no like length relationship. Yeah, it's not a midpoint. There's no length relationship between LM and MN. So if we're talking about this is the length of the segment, M could be here, M could be here, M could be anywhere. So when this happens, instead of being equal to each other, I'm going to add them together to equal the whole thing. So when you see that word between, the two pieces get added using segment addition to equal the whole length. Not necessarily. Yeah, let me think of a scenario that I would, okay, so everybody understand why this gets set up this way? Because I know it's not I don't know, it could be a midpoint, but I'm not told it's a midpoint. I just know that it's between, and I know that this piece plus this piece will equal the whole thing, 24. So now I want to add the x's together. So I get 5x, and then 1 minus 2 is negative 1. Any questions about that part? Okay. Then add 1 to both sides. So 5x is equal to 25. Then divide by 5, and x is equal to 5. And then I always double check. It just said find x, so I'm done. And then for D we know it's a midpoint. So if I draw this picture again, L and M and N, I usually do this and I put midpoint underneath it if I know it's a midpoint. That's just for me, so I know for a fact, okay, when I see that, that tells me this part and this part are equal. And 5x minus 1, those are equal, so I'm going to solve that. I'm going to subtract 4x from both sides. Or you could subtract 5x from both sides, it doesn't matter which. Then I add 1 to both sides, and I get 4 is equal to x. But I'm not supposed to find x, I'm supposed to find ln, which is the whole length again. So I'm going to plug 4 into here. So that's 19. 16 plus 3 is 19. That's lm. So mn is also 19. So ln is equal to 19 and 19, which is 38. There's my final answer. All right, so we have some more vocabulary. An angle is formed by two rays sharing a common endpoint, and that's called the vertex. So we have two rays, and they share that common endpoint. A ray is a straight line extending from a point. We talked about that already. And the vertex is the point at which the sides of an angle intersect. So here's our vertex. Now, when we named lines, the order of the letters didn't matter. But when we named a ray, the order did matter. In an angle, the order of the letters matter. So if we have an angle, and we have, say, P and Q and R, the vertex has to go in the center of the name. Because that's telling you that that point is the vertex. So to name this angle, you can name it angle PQR, or you can name it angle RQP. The other two letters can flip around that middle letter, but the vertex has to be in the center. So both of these are correct. If you were to say angle QRP, for example, you would be going from here to here to here. So it's a different angle, because that would put R as your vertex. So you want to be really careful with that when you're naming your angles. You take that away because you can't have it. Any questions on these at all? Right, we also have protractor. A protractor is a semicircular instrument. You guys remember these from like middle or elementary school or something? Used for measuring and constructing angles. An acute angle is cute, it's little, less than 90 degrees. A right angle is exactly 90 degrees. It's also perpendicular. So perpendicular is 90 degrees, is a right angle. They're all equivalent. And an obtuse angle is greater than 90, but less than 180. Now, you can have angle measures of more than 180 if you go around past the halfway point on a circle. But when we talk about acute or obtuse, any angle that goes past that halfway point is coming around, and we measure it over here instead. So we never measure an angle more than 180 when we're just talking about angles in geometry class. So examples of what these would look like. Lost my pen. 0, less than 90 degrees. Exactly 90 degrees, and now it'll be indicated by a little box in the corner, and then definitely more than 90 degrees. This is very similar to the ruler postulate, which tells me that I can take a half circle and I can number it from 0 to 180. And that way I can measure angles. You don't have to write that down. So for example, I have this angle ABC, or you can make a little angle symbol ABC. You can either write out the word or you can write the symbol. Don't just write ABC though, because then I won't know what you're talking about, because ABC could be measuring or used to name an angle, a triangle, or a plane. So I need to know which one you're talking about. Okay. We have ray BA. We have ray BC. And that's kind of what this tells us. This tells us that B is the vertex, so we have a ray that way and we have a ray this way. We have acute, obtuse, and right angles. And again, the way I remember that the acute angle is the less than 90 is it's cute. It's little. Little things are cute. You know, like puppies and little baby bunnies and kittens and angles. Okay, now, when we measure with a protractor, you can read it two directions. So if you look at the outside, I'm going to hopefully it's picked up. If you look at the outside, you see you have 180 and 0 here, and then 0 and 180 here. Which way the angle opens up. So if you're measuring it and it opens this way, you always want to start at 0. Whereas over here, if you're opening this way, you're going to use the inside numbers. So you read it 0 to 180 from the inside going this way, or 0 to 180 on the outside going this way. Some protractors are opposite on that. No, actually this one's the same. But some of them might have the 0 on the outside on this side, and the 180 on the inside. So you want to just look. Bought myself some extra feet. Okay, when we measure with a protractor, you want to line the angle up right in the center, that dot, or if there's no dot, there will be a bold line in the center. You want to line the vertex up right on that line or that dot, like that. Okay, the bottom of the angle on a plastic protractor that has a dot or a hole in the center will have like a line that goes across this way through the center of the plastic. You'll line up right on that. Or if you have a protractor like this that doesn't have that line, you'll line up the angle along the bottom edge of the protractor. So you can see on that one you're lining up on the line top, or you'll line on the line on the bottom, depending on the style of protractor. You want it to hit the 0. See, for this one, the 0 is up there. On this one, the 0 is right here on the edge. Then you look to see where the other side of the angle is hitting. Now, sometimes the angle is not big enough. So, for example, if I was trying to measure one of these little angles with this big giant protractor, I can't. It won't reach. If that happens, use the edge of your protractor as a ruler straight edge and draw the line longer. That way it'll hit and you can accurately measure instead of trying to guess where it would hit. Just draw it longer. So to find the measure of this angle, as you can see, here's our 0. So we're going to use the outside numbers, not the inside numbers. So 120. Another quick check, if you were to look at that and you would say, oh, 60, then look at the size of the angle. If it's bigger than straight up and down, then you know it has to be bigger than 90. So then you could say, wait, that's too big to be 60, that must be 120. So these are just ways to catch yourself. So this one is 120 degrees, always degrees. All right. To classify as acute, right, or obtuse, some of them you can just look at and you'll be like, okay, obviously that's less than 90, that's acute. Some of them, if they're close to 90, you'll want to measure them to make sure. To make sure if it's acute. If it's 89, it's acute. If it's 91, it's obtuse. It has to be exactly 90 to be right.
Will the right angles always have a square?
Not on this assignment, because on this assignment I want you to measure them. But when we're doing other things with angles later, it'll have a square to show you that it's right angle. But on this one, since I want you to identify it, I want you to measure it. Some of them will have a square, and some of them won't. So less than 90, it's acute. And we could double check that if we wanted to, just in case anybody was just like, well, are we sure it's less than 90? Well, let's check. Vertex goes right on that center. This lines up on the bottom. I read it this way, it's 35. Odd, definitely less than 90. So we're good. So obviously you guys can't from your seats measure C and D, but you can tell obviously if, at this point if they're right or obtuse. So just together, what do you guys think A is? I meant the measure, sorry. The actual measure. 130. And then for B, 105. And then C is, so right angle, and D would be, now just tell me if it's acute or obtuse. That's obtuse. Good job. Acute angle. Okay, for this one, I want you to find the measure and then tell me the classification, so you're going to do both. So the measure on this one would be, anybody? The measure, the angle measure. 35, and then that would make it cute. See? I told you guys would like this section.